Okay, students, so there are some properties which I don't think you need to memorize all these things. Even then, I have given here, you can note this down. Okay, now proof C here I will give with the help of Venn diagram only. So see carefully, very simple proof. So the first proof is, first property is number of element in A union B is equal to number of element in A plus number of element in B. So see why, when it will be happen like this, if A and B are disjoint. So see carefully the proof of first one. This is suppose universal set and you have a set A and set B, and I'm drawing this one separately. Why? Because I'm considering suppose it is disjoint. Okay, AB. Now see, A union B will be which one? This plus this, right? When you write A union B, what are the elements? You will write all element of A here, then all element of B here. All you will write here because nothing is repeated here, right? So all element will be different. So all everything of A you will write here, everything of B you will write here. So number of element, when you will find out what you will do, you will count the number of element here, right? Now to count this one, how many element will be there from A? You just count from here. So that is number of element in A plus, you will count this also, right? Number of element in B. So this become property. Now when this is disjoint, then only you will get number of element in A union B equal to number of element in A plus number of element in B. So you need to understand this thing from the Venn diagram. Okay, don't memorize it because this is only three form property which they have given. It can be extended also, means you can make more formula out of this if you understand this property. Obviously in your exam also and your textbook also consist of only question where it will consist only three sets. Okay, but you can make more formula. There is four you can make for A union B union C union D. Four set also you can make a formula, five set also, but for that you need to understand the property well. Okay, so next is C. What if it is common element? There is a common element between these two sets. Suppose I draw A B, then what will be the number of element in A union B? Now see, A union B, when you will write, what you will write? A union B, when you write down the set, you will write all the element of A here. Now when you will write B, you will not write this portion again because this you have already written in the set. So which one you will write? You will write only this portion here. Okay, so when you count the number of element for A union B, you will count here like this. You will count for A all, suppose. Okay, now B all element you cannot count because this portion you have already counted here, right? And this will not come here in A union B again. Only this portion will come. Okay, so what you can write from here is A number of element in A plus. Now this portion how you can write? You can write like this also. A difference, sorry, B difference A. Like this also you can write. This also can be formula. Number 2 I have written like this, right? That's why I said you need to understand. And last class only I said that you don't need to memorize all this actually. But still, see here how I can write in this format also. So see here is carefully. Instead of writing like this, can I write like this? Number of element in A plus I will write number of element in B. But see here, when I write number of element in B, I'm counting this one again, which I have already counted here, right? So I have to remove this counting for one time. So if I want to remove this counting for one time, means I have to remove this, whatever number of element here, I have to remove one time. So here, how many number of element will be there? How to find out? A intersection B first find out. This intersection you find out how many it is there set. Then count the number of element here. So number of element in A intersection B we used to write in this format. So what I will do, I will remove this for one time. A intersection B. This common portion I have removed for one time. Because I have counted here also, right? So two times I cannot count because when you write A union B, you will write this portion, whatever elements are there. Then you will write this portion. You will not write this again. Okay. But when I make formula, how I'll do? Number of element in A, I have written number of element in B, means I have counted this one again. Two time I have counted. So one time I have to remove. So one time I have to remove means what you do? Count how many elements are there. So that you remove one time, means intersection you remove one time. Okay. Now this formula is very important here. Why? Because using this concept, the concept which we have used here to derive this, we will use here also. Okay, And again I repeat, this is not only the formula. I have shown you another formula also. This also can be used as formula. Okay, same meaning this one also. Okay, but you will see practically we will use mostly this one only. Better remember, if you want you can memorize this also. Okay, but with understanding. First understand and then memorize. Why I said memorize? Because this will help you calculate the problem in a short interval of time only. Because if you simply get the concept also and you won't practice and won't memorize, then what will happen? You can do the problem for sure, but it will take time. Okay, but which you cannot let them happen in exam, right? Because in exam you have to do it within short interval of time. So you can memorize also if you want, but for that also you need to understand. Okay, so next proof, see, exactly same way we will prove this third one. So see here, it might be a little complicated for you, but see, whatever I will explain now with the help of Venn diagram, you try to analyze that step by step. Whichever step you didn't understand, don't go further. Means while explaining, I will explain everything, right? Now when you listen, part by part, try to understand it. After understanding only, you move to next part, okay, whichever I'm explaining. So see carefully here. Now I want to find number of element in A union B union C. So I will take set to be like this. This is little complicated. If you can derive formula for this, then you can derive for any kind of, like if you have 3 set like this, then you can derive for this also. If you have set like this 3 set, you can derive for this also. Very simple, these things. Okay, so if you have set like this, means all 3 sets having something common in the case. You can see this belongs to A, this belongs to B also, this belongs to C also, having common between 3. Okay, and this portion, if I consider this portion, if you see well, if I consider this portion, then this belongs to A also, this portion belongs to B also, but this portion you can see it does not belongs to C. Okay, this is common between A and B only. So diagram you have to see carefully. This is universal set, suppose. So I want to find out how many number of elements are there in A union B union C. If they give you set directly like 1 2 3 is their element like this, then you can easily find out how many element will be there, right? But if they don't give you direct question like that, and they will not give you directly set like this, okay, B set is this, C set is this, then find this. They will not ask like that. They will ask question indirectly, and we will see those kind of question in miscellaneous. Okay, mostly we will see this kind of question in miscellaneous, and in exam they used to ask 6 marks question based on this. So listen carefully and try to understand. It's very simple chapter. So see here, this is A, this is your set B, this is your set C. Okay, let me take different color pen. So see carefully. I want to find in A, B, C how many elements are there. All the elements I want first. So when you write down set A union B union C, this will be a set, right? So how you will write down the element? You will write down all the element of A, then C, this portion. If you write all element of B here, for example here I will write down so all the elements of A, suppose. Now when you write down B, you cannot write down this element again because you have already written here, right? So you will write only this portion. Okay, so you have written, suppose, this portion elements. Now when you write C, you cannot write everything. This portion you have already written, this elements you have already written, this element you have already written. You have to write only this portion. So you have to write that element. So those will be the element, and then you will count, right? Now the question is, I don't have any elements here. I have to make formula for this, right? A union B union C, how many element will be there? Number of element I want to find out. So how I will find out? So see carefully. First, suppose I will write number of element in A plus number of element in B plus number of element in C. I will prove like the previous one, like this. First I have written for this one, see, number of element in A union B I have to find out, right? So what I have written, number of element in A everything and B everything. Now I will remove those which I have counted 2 times here. So from here and here you have seen that A you have counted all the elements. In B also you are counting this portion again. So again means 2 times you cannot count, right? Because this element will be only 1 time in this set. So this portion we have removed like this. Same concept we will use here also. So see carefully. I have written all this element. Now see here. when I write number of element in A and number of element in B, so see carefully, number of element when I write, I have counted. This diagram will become little dirty, okay? You just see carefully and analyze what I am saying. This element you have already counted, right? Number of element. Now when you count B, you have written plus number of element in B. Now when I write like this, I am counting this one. I'm counting this one. This is your B. Okay? Now see, when you count this, what you are doing? Between these two only you have written this one 2 times. So this portion I have to remove, right? So let's remove that. So in the formula, where is my pen? In the formula, I will remove number of element in A and B, common this portion, because this I have already counted here, right? Now when I write number of element in B, I have written number of element in B directly, everything I have written, right? Plus this I have written, means this element I have counted, plus this element I have counted, means this portion I have counted 2 times. So I have written 1 time, remove 1 time, number of element A intersection, this portion I have written, remove once. Okay, so I hope you have understood till now. So I have counted this element plus this element now. I have not counted this one 2 times. Okay, so see carefully next. Next I have written plus number of element in C. Let me take another color. C. Now when you write number of element in C, you have counted this portion. Right? Now see, when you write this, you are counting this portion again, and this portion also. This portion already counted here, right? Once you have. Okay, in A you have this portion. So this portion you are counting again. So 2 times you are counting, right? Because see, you are counting this. Now when I write number of element in C, you are writing this whole thing. All element you are writing. So this number, this element which are there, you are counting there also, this also, this also, this also. So this we have already counted here. So this portion you cannot count again, right? So I have to remove this portion. Now simply I cannot remove this one. I can, but I have to make another formula for that, right? So what I will do, I will remove this portion, because this portion also you have counted again, because this is already counted here in A. Right? Now why I am not saying in B? Because I have removed that portion once, right? If you have not understood the previous part, you first analyze that one. You have to think yourself and have to understand, okay? Then come back to this, which I am explaining. So listen carefully, pause the video and try to analyze whether you have understood this part or not. Then you go back to next, okay? So see here, this portion I am counting again. So can I write minus, what I will do, I will remove this portion again. B intersection C. Number of element in B intersection C. So I have removed this portion, means what? I have removed this portion, right? Which you have counted 2 times. So done. Now the problem is solved. Till now you have counted from A only 1 time, this one 1 time, this one 1 time, this portion 1 time. Okay. But here there is a problem. This portion problem is solved, right? But this portion, you see, this portion you have already counted in A, right? When you write number of element in A, you have counted already. So but you have written here number of element in C. So you have counted. When I write number of element in C, you will count all this element. Now from that, this portion was coming 2 times, so I have removed that portion. So problem solved there. But this portion, what about this one? I have to remove this also, right? Again. Now this portion, how I will write? What I will write here for this one? So for this one, right now I don't know, right? I can make for this also, okay? And in miscellaneous we will do this problem also, how to solve it. We will try to find out there also. But see here, in this case, how I will write? This is common portion between A and C, but not between B. So what you will write for that? So to make simple, what I will do, can I write like this? Instead of removing this portion, I will remove this portion, suppose. Okay, this whole thing, because this whole thing is what? A intersection C. This is common region between A and C. So if I remove this one, This you have counted only one time, right, till now. So when you remove this whole thing, you are removing this one completely, right? And this one time you have removed. So suppose I have written minus A intersection C. But when you write this one, this you have counted only one time till now, because I have removed whatever two times was there, I have already removed that, right? So only one time was there. Now you have removed, writing this one, you have removed this one totally, this portion. Okay, so you have to add this element again, number of element. What is the number of element here? You have to add this portion again. I hope it's clear. Step by step you try to understand and then try to analyze yourself and then move back to next part. I'm telling you this so that you can understand the formula properly. Okay, now this portion, what it is, you can see this is the common portion between A, B. This is lying within A also, B also, C also. This is the only region. So this region, what I can name it? A intersection, B intersection, C, common element. So here you count number of element, how many it is there, and that you add up. So this will become a formula. Okay, and using this concept only we will solve all the problems in your miscellaneous. Complicated problem we can easily solve this one, but before that you need to understand this one properly. Okay, so first what I have done, I have taken set A, counted all the elements. Set B I have counted again this one, right? So this portion I am counting two times, so that's why I have removed once, A intersection B. Okay, this will give one time the number of element here, right? So number of element in A intersection B I have removed one time, right? So done, problem solved. Till now between A and B I have counted only one time till here. Okay, now next I have written plus number of element in C. Number of element in C, the moment I write means I am writing everything here. Whatever number of element is here, I am counting everything. Now see, this portion you have already counted in B. So I have to remove this portion one time, and this portion also I have counted in A one time. Okay, now I'm not saying in B because I have removed one time, right? So I will just say suppose in A I have counted this portion again. So I have to remove this portion one time again. So that's why I have removed B intersection C, this one time remove. So till now problem is solved. But the problem here is this one again. This portion you have counted in A already. Now when you write number of element in C, you have counted this one again. So you have to remove this also again, this portion only. Now this portion I don't know what to write right now. Okay, so what I have written, I am removing this whole portion. So when you remove this whole portion, this you are removing totally, means this element you have not counted at all if you remove this one. So I have to count this element again. So what I can write this one, add plus number of element in A intersection B intersection C. Okay, so if you have understood this one, you can derive any formula, A union B union C union D union E, whatever number of set you have and whatever kind of picture they will give, you can derive any formula. Now I will show you this one how to derive. See, from this part only I can derive now. That's why I said this is the general form. Okay, if you understand this one, you can derive any set element. Okay, suppose you have this kind of set. So what will be the number of element? A union B union C. How to find out? This is A, this is B, this is C. Okay, this is a practical problem. A, B, C. So this is common region between A and B, common region between A and C. So see carefully. This one, number of element in A plus number of element in B, number of element in C, directly I have written, suppose. Okay, so if I write like this, number of element in A means this one I am counting. Number of element B means I am counting this portion again. Okay, so I will remove one time. A intersection B. Problem solved till here. Now number of element in B, when I written this one, this portion also I have counted, right? Now plus number of element in C, when I write this portion again I have counted. So this one try to remove one time. A intersection B intersection C. This will become formula. Now this formula I can derive from here also. You don't need to use concept here. With this only you can find out. So see carefully here. For all kind of A union B union C, whatever picture you have, you can use this formula. Why? See here carefully. Number of element in A union B union C, what formula I got? Number of element in A plus B plus C number of element in A intersection B, B intersection C, A intersection C plus A intersection B intersection C. So I will simply write down, suppose here, formula minus this minus number of element in A intersection C plus number of element in A intersection B intersection C. I have written, suppose, okay, directly formula I have written. Now this value you can find out this. See here, this portion is this one, this portion is this one, this portion is this one, right? Now see, from this portion I have got using this concept I have got formula till here, right? I didn't got this portion. Why? So see carefully, I will find out A intersection C, how much it is. A intersection C means common element between A and C. Is there any element, common element between A and C? They are disjoint set. So what element you will have? Nothing. You will have no element common between A and C. So how many number of element will be there? 0. So you will get 0 for this. For this one, number of element between A intersection C means common between A, B and C. 3 set having any common here? Nothing is common. You can see A and C already disjoint. So what will be common between A and B? A, B and C. All 3, there is nothing common between all 3. So 0 for this also. Okay. So basically you will get 0 here, 0 here. So vanish this one, you will get this portion only. Is it clear? So A intersection B, this portion whatever it is, you just write down number of element here. This portion whatever it is, number of element here. Number of element in A you write down, B write down, C write down. Solve this one, you will get the answer for this. Okay. So if you have picture like this also, you can easily solve using this formula only, this one. Okay. Here between A and C nothing will be common, so A intersection C 0. B and C nothing common, B and C nothing common means this also will be number of element in B intersection C also will be 0. A intersection B intersection C nothing common between 3 set, right? Altogether you can see there is no common between 3 sets, so this also will be 0. So A intersection B, this portion whatever number of element you just write down here you write down. Solve this portion, you will get the answer. This will be 0 0 0. Okay. So whatever kind of picture you will have, you can easily solve with this formula only. So this is the general formula for you. So you better write down all these 3 property. If you want, memorize it. Okay. But with understanding. Okay. If you won't understand, then it will be difficult to understand the question and solve it, because this you can use only if you understand the question of the problem. Okay. So with this we will start 1.6. 1.6 is very simple exercise. Miscellaneous question you will need this concept which I have explained in detail here. So analyze all those things properly and try to understand first these things, then go for exercise. Okay. If you don't understand this one, try again. If you still don't understand, ask me. I will explain again this one in a different way. Okay. So now you also can try 1.6 yourself. Very simple exercise 1.6. Okay. So some question I will take. So your first question, you see, if X and Y are 2 sets such that number of element in X is 17, number of element in Y is 23. Number of element in X union Y is 38. Find and number of element in X intersection Y. So they have given number of element in X. Solution you can write like this. Okay. Given number of element in X equal to 17. Number of element in Y 23. Number of element in X union Y is given 38. Means altogether 38 elements are there. Okay. Out of that 17 will be in X, 23 in Y. Now if you add up this one, you will get more than this. Now why? Because intersection, common element also will be there, because you have counted 2 times here. So they have asked you basically find out X intersection Y. Okay. So see here, this is your X, this is your Y. X you have some element. How many elements you have? Altogether 17 elements. Altogether in Y, how many elements you have? 23. So obviously if you add up X union Y, when you find out, obviously it will be less than this. Why? Because when you write number of element in X 17, you have counted this one. Number of element in Y 23, you have counted 2 times this one. So X union Y obviously will be less than addition of this one. Okay, that's why this is 38 less than this. Okay, anyway, so we have to find out x into what is the number of element in this common region. So for that I have formula, right? X union y. What is the formula? Number of element in x plus number of element in y minus number of element in x intersection y. So I have to find this. So better bring this one this side so that it will become positive. This will bring this side. X intersection y is equal to number of element in x 17 plus 23 minus, this will be minus, right? Minus 38. Solve this one, whatever comes out that will be your answer. Okay, so 23, 33, 40 minus 38, so this will be 2 only. Okay, so you can understand 2 element will be common here. Next, number 2 is exactly same, you do yourself. Okay, number 3, in a group of 400 people, so there is a group, there are how many people? 400 people they have said. 250 can speak Hindi, 200 can speak English. How many people can speak both Hindi and English? So see here, they have said there is a group of how many people? 400 people. Total there are 400 people. So out of this they have said that 250 can speak English. Okay, 250, right? Yes, can speak English, and out of this 200 can speak Hindi. So see here, if all people who can speak English are different, means they cannot speak Hindi, suppose, and the one who can speak Hindi, they cannot speak English, then obviously this people will be totally different, this people will be totally different, and if add up how many people you will get? 450, which is more than the group. Not possible, right? Means what? There are some people who can speak both English and Hindi. Okay, so in the group of people who can speak English, those people also are included who can speak both Hindi and English. Here included, they have counted here, as well as here also. Okay, this is a people who can speak Hindi. It does not mean that these people cannot speak English. There might be some people who can speak English also. They have just said that these peoples are the one who can speak Hindi. They might be able to speak English also. Okay, so it's obvious, right? These people can speak English. These people, out of this 400 people only, these people can speak English, these people can speak Hindi. So obviously there must be some people who can speak both Hindi and English. That's why they are counted here also. Those people are counted here also, here also. That's why you're getting total 250. I hope you have understood. If you draw a Venn diagram, this is a people who can speak English, suppose. Okay, and this is a people who can speak Hindi. So all together, that is E union H. All together, how many people are there? 400. Right? In this English and Hindi speaking people, there are group, how many people are there? 400 people, right? So out of that 400 people, 250 can speak English and 200 can speak Hindi. So obviously there must be some people who can speak both Hindi and English. That's why in total you are getting here 450, which is not possible. Total is only 400 people you have. Okay, so they have counted those people in English also, Hindi also. Okay, so how we will find out? So just write down here, let E be the, you can write this one, solution number 2. Let E be the set of people who can speak English. Okay, and let H be the set of people who can speak Hindi. Okay, therefore given, according to question, what is given? Number of people who can speak English is how many? 250. Number of people who can speak Hindi, how many? 200. And how many people are there who can speak Hindi, English, everything? What are the total number of people? 400. Right? 400 people are there, out of which they have said 250 can speak English, 200 can speak Hindi. Right? So out of 400, how that's possible, right? If it is totally different people who can speak English and they don't know at all Hindi, suppose, and the one who can speak Hindi, they don't know at all English, then total how many people will be there? 250 plus 200, it will be obviously 450, which is not possible. So there will be some people who can speak both this language. Okay, so number of element, I want to find out how many people are there who can speak both language. Common, right? This is the symbol I will use. This intersection means what? In English also will be there, in Hindi also will be there, both, right? Means there will be a people who can speak English and Hindi, both intersection. So I want to find out this one. So how I will do that? We know formula, number of people in English plus number of people who can speak Hindi minus number of people who can speak both. So I have to find this, right? So bring this one this side, number of people who can speak English and Hindi both. That's why I said in maths, n, whenever there is n, use intersection or union. In plus minus form, or means plus, n means not minus, n means multiplication. Okay, in set, this operation n means intersection, or means union. Okay, if you want to analyze that, which sentence you try to analyze? When you use or, what you used to do? When I say find the number which divides 3, or what I will wait, let me give example, proper one. Find the number which are divisible by 3 or 5. When I say this word, what you will find? You will find those number which are divisible by 3 or 5. They have said one of this must divide, right? So what will be that number? 3 can I take? Yes, of course. It is divisible by 3 or 5 they are asking. So if it is divisible by 3, I can take this one, right? What about 5? Can I take or not? Yes, 5 also I can take. 5 is divisible by 5, right? They have said find the number which are divisible by 3 or 5. When I say or, I can take either divisible by 5 or 3. Any one I can take, right? Means you will add this element also in the set. Okay, so or means always plus. You will add whatever element you will get for this, whatever element you will get for this, both you will add and will get the total. Okay, anyway, just try to understand. Union means plus, we used to take, intersection into, or you can say common. Okay, here whenever there is n. So this one you just use the formula and find the solution. Okay, this you bring this one this side and then find the solution. The time is already up. Okay.